Hello and welcome to another Jog Vlogs revision session. This one is going to be dealing with paper 3 topic 1 and very specifically the rivers physical fieldwork element. So just to give you an overview of paper 3 as a whole, it includes 64 marks in total and lasts an hour and a half. And topic 1, which is what this PowerPoint is going to address, is all about the physical environments fieldwork that you've carried out. Now this one is very specifically looking at rivers because that's the one that we carry out at our school, so make sure that you're obviously also looking at rivers. I'm not going to be dealing with coasts on this one, but this is optional because you don't do both of these two topics, you pick one or the other. The second topic is about human fieldwork, which again we're not going to cover in this PowerPoint. And the third area is about the UK challenges, which is a synoptic area which covers how topics from papers 1 and 2 interact with each other in real life kind of scenarios for challenges facing the UK. So for example, looking at landscape challenges, we identify things like river flooding and how river flooding links to things like building on floodplains and changing cities, etc. So topic 1 and 2, the fieldwork sections, both are structured in a similar way, and it's not too confusing. I'm just going to try and say this as clearly as possible, and then you might want to go back over it to make sure you understand fully how it's going to be assessed. So just like other topics, it's got shorter questions of 1, 2, 3 or 4 marks and an 8 marker, and the 8 marker will be assess or evaluate. So that's pretty commonplace. When you've been looking at other topics in the past, that's how they've been structured too. The thing that you need to be aware of is that when it comes to the fieldwork, one set of questions, like the shorter questions, will be about either your fieldwork, specifically your fieldwork, or fieldwork in general for rivers, for example. And the 8 marker will be about the other thing. So if the short questions for the rivers topic are about fieldwork in general, the 8 marker will always be about your field work specifically. And if the 1 to 4 mark questions, the shorter mark ones, are about your field work, the 8 mark question will be about someone else's field work or field work in general in rivers. Okay, now if that's the case for topic 1, let's say the shorter questions are your field work, the 8 mark questions someone else's, the opposite is true then of topic 2. So the human field work would then have short questions on someone else's topic and then an 8 marker on yours, and it always goes in that pattern. So the opposite is always true of the second paper. So make sure you just kind of read that and fully digest it, because you know if the short questions in topic 1, the rivers fieldwork, about your fieldwork, the short questions for topic 2 will be about someone else's fieldwork or fieldwork in general. Okay, now for this particular topic, which is topic 1 of paper 3, I'm going to give you an overall summary, but I'm going to kind of also provide you with detail about linking it to the exam paper with exam questions and pupil responses. So you'll get an introduction to each kind of key aspect of fieldwork that they could ask you about. You'll also get a summary of your fieldwork investigation specifically, so you can see how your fieldwork ties into these 7 investigation kind of fieldwork investigation aspects. Then I'll give you exam questions that are within that particular aspect of fieldwork inquiry, with a model answer if it's available, and an examiner's report. And the examiner's report tells you what pupils did for that whole cohort. So every pupil in the country that answered that question, what they did well or what they did less well, and pitfalls to avoid. So examiner's report stuff, although it's a bit dull, is incredibly useful for you. So the 7 aspects of fieldwork, which are true of both topic 1 and topic 2, are firstly developing inquiry questions. So you need to either know your inquiry question, well you do need to know that, or you need to be able to develop an inquiry question by looking at a photo of a place, for example. They could ask you about location, so your location or location in general. Why is this a good location? Why isn't it a good location? Sampling, they could ask you about within site selection and in your methods of data collection. They could ask you about methods of data collection specifically, so describing it, justifying why that's going to help you. Tell me what equipment you used. For the equipment, for example, there was a question in the past where they asked you, name a piece of equipment used to measure velocity of rivers. Okay, and you needed to know specific pieces of equipment that you would need to measure that. Evaluating your methods of data collection, also very commonplace. Methods of data presentation. Again, can you describe how you presented the data you collected? Scatter graphs, bar charts, sketch maps. Could you justify why you used it? Could you tell me alternative methods that maybe are better to use if they've got lots of disadvantages? Your conclusions, or the conclusions you could draw from some work that's presented to you, how does it link to the topic? How does it link to your inquiry question? Is it reliable? Is it accurate? And then finally, your overall evaluation. So again, what further study opportunities are there from doing your investigation? How many sites could you visit in future? Could you go at different times of year? Could you make it more reliable, more accurate? So those are the 7 different areas of questions that examiners use to kind of test your knowledge on fieldwork. Because remember, as an exam, not coursework, this really wants you to show that you know how fieldwork is carried out, and from people's kind of fieldwork what conclusions they could draw from it. So we're going to start with looking at number 1, so developing inquiry questions. So you must know inquiry questions from your fieldwork specifically, but you also need to be able to formulate questions from looking at an area specifically to do with rivers. Now, I've put in bold and red here that you can pretty much always talk about how does this river conform to the Bradshaw model. That is a pretty much get out of jail free response that for whether it's someone else's fieldwork and indeed your fieldwork, we actually use that fieldwork inquiry question. You could look at the impact of rivers with regards to flooding on people. That's another one that is very common that could be used. And between those two, you're pretty much going to be covered for any potential exam question about formulating inquiry questions. So as you need to link a question, or maybe your key question, to your conclusions or your methods, you must know what your inquiry question is, but also you need to know what your inquiry question's hypotheses are, and I'll show you exactly why in a second. Okay, so this is the summary of your fieldwork and how this links to this particular part of the inquiry process. Your inquiry question is: do river variables change downstream as proposed by the Bradshaw model in the Swannington Beck? The thing that makes this your fieldwork is just that bit at the end, Swannington Beck. That's the specific river tributary of the Wensum that we looked at when it came to doing our does the river fit the Bradshaw model. So the overall inquiry question is really looking at whether the Swannington Beck fits the Bradshaw model from the data we collect. Now we have to divide that up into a couple of hypotheses, so a couple of theories. As distance downstream increases, discharge is going to increase. That's what we think, that's our theory. And another theory, okay, and that's a justification of that theory. This links really our hypothesis to the Bradshaw model, because it'll help me work out if the river's getting wider and deeper as we move from upper to lower course. Then we know that it fits the Bradshaw model, because actually the Bradshaw model proposes that the river gets wider and deeper, and that would also lead to it maybe increasing discharge because it's got a wider area to carry water. Hypothesis 2 is as distance downstream increases, so bed load size should decrease, and once again that very much links to the Bradshaw model. So this is again a theory that we think is going to be the case. We expect the size of sediment and the roundness of sediment will get more rounded and smaller as we go downstream. That's what we expect to happen, because that's what the Bradshaw model says. So again, this will help us identify if there's attrition going on. It'll tell us whether there's potential risk from erosion, if there's lots of sediment in the river. It could also tell us again whether our river fits the Bradshaw model. So this is a summary of our fieldwork. I would urge you to write this down, or to dig out your fieldwork sheet where this information should already be written. Okay, so how does this look as an exam question? Well, okay, then there's the Bradshaw model just as a reminder. Okay, so this looks like an exam question here. We've got explain, so we've got to give reasons how our question or hypothesis helped our investigation for 3 marks. So it says you developed at least one question or hypothesis. Well, we've got 2 on the last slide. Go back and look at them if you want to. Hypothesis to help you investigate a river you've studied. Explain how this hypothesis or question helped your investigation. So you need to actually write one of the hypotheses here. You don't get any marks for it, but you need to write it. And the reason you need to write it is because you then need to explain underneath how that helped your investigation. How did looking at or thinking that discharge would increase downstream, how did that help us find out whether the Swannington Beck links to the Bradshaw model. Okay, so that's how you explain this. Now I'm going to show you the exam answer or pupils' response that we got from this. Okay, or this is the mark scheme, sorry. So it says award 1 mark for identifying a point and further marks for an explanation of how this inquiry question, or this hypothesis it should say, helped the student investigate the river. So the hypothesis is clearly linked to the candidate's fieldwork investigation. For example, the width and depth of the Untitled Beck increases downstream. That's a hypothesis. So we would say the discharge of the Swannington Beck increases downstream, something like that. So once you've written the inquiry question, you don't get any marks, remember, for that. This is where the marks are awarded. So my inquiry question supported my understanding of the aims of the investigation, or the focus of the main aim. How they've got a mark for that, I don't know, to be honest with you. Through exploring the changes in width and depth of the river, as well as other characteristics, to decide how the river changes in relation to the Bradshaw model. The Bradshaw model bit is the key bit. You'll get the marks there. So if you just copy out the bit that's written underneath the hypotheses, okay, in this answer, then you'll get 3 marks for that, okay, but you must also memorize your hypothesis. Now this is the examiner's report, and this is how they show you. Rather than you read this one, and I won't always read them out, I'll read this one out for you. So in this question, candidates were asked to explain how one of their questions or hypotheses helped their investigation. This question proved the most difficult for candidates, resulting in almost half the cohort achieving 0 marks. So look, if you can get 1 or 2 for this by linking it to the Swannington Beck, you're already onto a winner. Some candidates were able to recall their question or hypothesis, but did not go on to articulate, that's tell them, how this helped their river investigation. Where candidates achieved 2 marks, responses did identify how the question or hypothesis had provided a focus, which was then developed to say how that translated into practice in respect to their fieldwork. Candidates who scored 3 marks made reference to the Bradshaw model and clearly explained how they had used their question to focus their fieldwork collection methods. Okay, so we measured the width and depth to measure the discharge, because that gave us the volume of the river. That then allowed us to see whether there was more discharge in the Swannington Beck, which we should see as it approaches downstream, which links it to the Bradshaw model. Something like that. But look, people did really poorly on that, and the reason I think that people did very poorly is because students don't memorize everything they need to do from their investigation. So look, the trick is memorize your inquiry question, memorize your hypotheses, make sure you know it, and look, at the start of the exam, just scribble them down or get a note form of them, just so you can use them, because they are going to be useful at some point. Okay, so the second aspect of fieldwork investigation then is looking at location. So you could expect to maybe explain why your location was a suitable place to study river processes. You can't just say because it's a river. Okay, that's too vague. Now what I mean by that is you could say something like the river was small, so we were able to go to lots of sites in one day. So that tells you why a small site is suitable. It's a good location to use. You're justifying why you've chosen the Swannington Beck. So it's small, so we could go to lots of sites. It was local, so we didn't have to travel very far. We could get there easily in a day. We could get better access to it. You could also be asked, however, about some of the limitations. That means problems with your study site, because we know that not every site is perfect, and so even though the Swannington Beck is small, so we could go to lots of sites, and also local, so we could travel to it in a day, it did have some problems, and those problems were that it was small. So if we are looking at changes according to the Bradshaw model, then we're not really going to get a massive range of data. When you think of big rivers, they're hundreds of miles or hundreds of kilometres long, you're going to see changes. But when you're looking at a river that's about 10 kilometres long, the Swannington Beck, that's about 10 kilometres, then you're not going to necessarily see that dramatic a change in that length of time or that distance. Also, even though it's a small river, it still goes over private land, and people that own that land we don't have access to. So we couldn't actually go to all the sites. Even though there's only 9 of them, we could only go to 3 of the sites. So you could also be asked to say how your study area could be affected if there was a flood or there was river erosion. So you need to know about the area around the river. All right, so the next slide is going to give you that. Now, once you've copied this information down, because this is how your investigation links quite nicely to this particular aspect of fieldwork investigation, I'm going to show you these study sites. So here are our theoretical study sites. We didn't go to a lot of them. We didn't go to Haringland Park Lake, which is the source of the Swannington Beck. We went to just a selection of 3 sites. And this map helps you with that last part on here, okay? How does your study area, how it could be affected by flood or river erosion? This is a bit of secondary data from the Environment Agency, and it's qualitative data. So this shows us flood risk in the area we're looking at. So over here, that little area there is a high flood risk, the Haringland Lake area. You've also got high flood risk near Nut Pit Farm, which is about here, just as you approach Swannington. You've got some flood risk over at Hengrave and sort of in Swannington. So again, it's this area where the little river, another little tributary, meets here. You've then got further flood risk a bit further south, which is where that river then starts to link into the Wensum down near Lemwade. So all of this kind of demonstrates your study areas and the area of land at risk of flooding. But this OS map is really useful because around the river you can see there are houses. I would mention things like Quaker's Farm. Quaker's Farm is clearly a place that's very close to the river. It is potentially at risk of flooding, although it's quite a low risk. You could look at Haringland Larter Farm, which again you can see down here there is a slightly high risk. It's actually medium risk of flooding along the road here, okay, which is just crossing the Haringland Farm there. You could also identify land. This is all farmland because it's low lying. Look at farm, Breck Farm. So all of these areas are farms, clearly saying that they're showing you that this is farmland, okay, because farms are located around farmland, surprise, surprise. So there is potential risk, not necessarily of properties, because there's not lots of houses there, very little pink kind of orange, peachy blobs, but there is quite a lot of potential to harm farmland. So farmland getting flooded, it has a financial cost, an economic cost. So there we go. Again, we can link, using our OS map, we can link the risk of our study area to things like flooding or land, risk to houses, etc. from flooding. Okay, so how does this appear in an exam? Here's an example of exam question. Explain, okay, one way for 3 marks, please. So this is where you've got to extend your answer a couple of times. Explain one way river processes might affect people living in the catchment area of the river you studied. So you have to talk about the Swannington Beck. The question specifically says you studied. So not everybody studied the Swannington Beck, only us. So you've got to now talk about the Swannington Beck and how processes might affect the people living in the catchment area. So you could talk about the fact that the area around the Swannington Beck is very agricultural, and therefore the flood risk suggests that areas like, and you can again mention places like Haringland in your answer, Haringland will flood. This could flood quite a lot of valuable farmland in the area. Okay, so something along those lines. Now this is the mark scheme. So 1 mark for identifying a process that could affect flooding or affect people, then explain how it's going to affect people. So commercial or residential properties, that means houses, located close to the river are vulnerable to flooding, tick, which could lead to damages to properties, tick, leading to other loss of income, tick. I mean, it's a very, very vague, not very good answer, but that it will work. Roads, we didn't mention roads actually on our thing, and our map shows roads. Roads are often damaged by floods, tick. That can result in disruption for people that use them, commuters, tick, which means they get to work later, tick. There's less farmland, this is a good one for us, tick, because the erosion of riverbanks or the flooding of farmland is fine, tick, leading to loss of income, loss of crops, tick. So this last one is probably our best answer because that one suits the Swannington Beck. So you could say the Swannington Beck could lose farmland in a flood. This is because the flood waters could, or the land is located next to the river, leading to loss of income or crops. Okay, 3 marks, done. So here's an example that someone put in a question, and this has got the examiner's report linked in. So in this question, candidates were asked to explain one way river processes might affect people living in the catchment area. Candidates were able to correctly identify a river process and explain how this impacted upon people. However, fewer candidates achieved the 3rd mark by developing this impact further. So that's your advice. Make sure you develop it further. Get the 3rd mark. Whilst there was no requirement for candidates to refer to the river they'd studied, some candidates did, which often led to a more descriptive response, not focused on answering the question related to the impacts on people. So this is actually being a bit contradictory. It's saying, oh, yeah, you need to mention the river you studied, but they're telling you that candidates that did say the river they studied were penalised, basically. So, river processes, especially erosion by hydraulic action and abrasion, can increase, so that's tick, can increase the size of meanders flowing through the floodplain. This puts more people's homes at flood risk, tick, therefore people may have to move house, tick. There's 3 marks there. So, talks about hydraulic action and abrasion, then it talks about potential flood risk on people's homes, and the fact that the people might have to move home. So there you go, you've got 3 marks there. So the candidate has stated the river processes, developed it by explaining the impact they have on people, and then they've used things like connectors like therefore people have to leave their homes. That gave them the 3rd mark, showed you how they access the 3rd mark. So the lesson here is use those connectives. Alright, so number 3, in section 3 of this particular fieldwork investigation kind of topic, you could have to look at sampling. Now what you need to know is what we mean by random, stratified and systematic sampling. We didn't use all 3 of these, but they could ask you, remember, about other candidates' fieldwork. So they might even just ask you a question, what is random sampling? And you need to be able to describe it. So you also need to know what method you used, and I'll go over that in a moment, and why that was a suitable method. So you need to justify it. Why did we use stratified sampling? Why didn't we use systematic sampling? Okay, you need to know that. So also, again, like I say, if other people's fieldworks used, try and identify what sampling strategy they could use for their investigation. So in summary, okay, we've got listed on this OS map is used again. I'll use that a few times. The 9 sites that we wanted to use. Okay, so we use stratified sampling to select 9 sites, and the reason it's stratified is that those 3 sites, one of them is in the upper course of the river. 3 of them are in the upper course, 3 are in the middle, 3 are in the lower. So we've got the same number of sites in each of the different aspects or courses of the river. We wanted to use systematic sampling, and you can see that we've tried to use it similarly, but they're not evenly spaced. Systematic would be, every kilometre along the river. That would be a really good way to do it. But we can't use systematic sampling for the Swannington Beck. And the reason we can't is because we can't get to all those areas. We don't own the land. It's not accessible, maybe. It might be in the middle of a wood or behind barbed wire. So as a result of it being either not accessible, private land, or too dangerous, we couldn't use systematic sampling. Stratified helped suit us better. And because of time constraints, we also actually only looked at sites 2, 6 and 7 when it came to collecting data. So site 2 in the upper course, site 6 in the middle course, and site 7 in the lower course. So we've got 1 from each of the 3 courses, which helps us maybe still have a stratified sample. Okay, now I can't give you example questions from the exam on sampling in the river section because they, when up to the point of recording this PowerPoint, they haven't actually been any. So I'm sorry about that, but be prepared for sampling questions. They have appeared in the human paper, so don't think they don't turn up. They do, and the fact they haven't appeared in rivers yet means that there's a higher likelihood they will appear in the next exam series. So section 4 of 7 is methods of data collection. So you need to know what we mean by these terms: quantitative, qualitative, primary and secondary. Know the definitions, because they could easily ask you just a generic question about what is primary data, or give you 4 options and say name the data that is qualitative. You need to know. Okay, it's more likely though that you need to name a specific type of quantitative data or qualitative or whatever in rivers fieldwork. So you'll need to know that quantitative data involving numbers could be something like measuring the width of the river channel. Okay, that's quantitative. You're measuring numbers bit by bit by bit. Qualitative data would be something that's got a bit more, not necessarily numbers involved. For example, using Power's roundness index is using qualitative data collection. It's secondary because it's someone else has done it. Power's created that index, and it's using one sheet to tell you what the roundness of all the different sediment you could pick up from a river is. Okay, so it tells you lots about certain things. So that's qualitative data. You need to describe in detail, including names of equipment. Your quantitative method was for measuring river discharge, and your qualitative method for measuring river landforms. Now they specify river landforms. Landforms, believe it or not, and sounds mental, but landforms, the exam board allow sediment in the river to be classed as a landform. Okay, so by doing Powers Pebble roundness, that is technically you using a qualitative method to measure river landforms, because the sediment in the river is classed as a landform. Alright? Because they were aware that lots of rivers available to students maybe don't have obvious landforms like meanders, oxbow lakes, river cliffs that you guys have learnt about in the rivers topic of topic 1, paper 1. So they do count sediment as a landform, and I'll show you that in a mark scheme that's attached to this particular section. You need to justify your methods. Why did you use this method? How does it help you answer your hypotheses? How did it help you reach a conclusion? You need to be able to justify that for an exam for some of the more challenging questions. And you need to also evaluate your methods. How are your methods maybe not very accurate? How could you improve them? What can make them more reliable? So those are the areas that you could be asked around methods of data collection. And I've got a table here which summarises the methods that you used, the equipment you used, what hypothesis it will help you with, and how you could justify that particular method, and whether it's qualitative, quantitative, primary or secondary. Now I'm going to reveal all of this for you. Okay, you can see how detailed it is, because I really want you to know enough detail about all of the methods that we used. So, sediment size and shape, river width and depth, river velocity, flood risk map, and field sketch. All of these things are methods of data collection that were certainly available to us. If you haven't done them, then that's down to you, but you need to know all of these. And the reason we need to have this many is we need at least one quantitative, we need at least one qualitative, we need at least one primary, and at least one secondary. So the sediment size and shape talks to you about what that involves. Description, you need to know that. It talks to you about the equipment we could use, and again, you could easily be asked about a piece of equipment used to measure sediment size and shape, so you could literally write calipers and get the mark. What hypothesis that we've covered, look back in this video if you want to see them, it will help us answer, and how, so this is justification. And then qualitative, quantitative, primary, secondary. So primary quantitative, the data we collect when it comes to, it says size and shape, but actually using Powers guide it shows it's qualitative as well as quantitative. So if we're measuring sediment size, that's quantitative. Sediment shape is actually qualitative using Powers guide. So you need to pause the screen or take a screenshot and read through and highlight this, because this is absolutely critical to any questions you get about methods, because these are the methods that we used, but not just that. These are the methods that pretty much anyone uses when they do rivers fieldwork. So we've deliberately given you everything that you could use for both our fieldwork and if you're given someone else's fieldwork to look at for the smaller questions or even the bigger questions. Okay, pause the screen while you're doing that, please. Take your time, it's worthwhile doing. When you're ready, unpause the screen and we'll look at evaluating these data collection methods. Okay, so evaluating these data collection methods, I haven't evaluated it in as much depth as I've given you the description, because you won't need to evaluate more than maybe two. If you get an evaluate question, you need to be able to evaluate at least two aspects. So I've chosen these two. You can just use these for your revision, because again, these will work pretty much in every case, whether you get it for your fieldwork or someone else's fieldwork as well. So velocity. Problem with measuring velocity, okay? Again, we can see on this slide, we did measure velocity using a tape measure, ranging poles, velocity flow meter. I've just picked one aspect of measuring velocity that could be a problem. Might be restricted by the other groups in the river. We went into small parts of the Swannington Beck, so anyone standing upstream from you could disrupt the flow. And so it could stop your velocity flow meter actually recording an accurate result. So that's the problem with the method. There were too many people in the river, and it's a small part of river. How does that impact results? Well, it meant that the velocity we recorded was probably slower than it should have been, which isn't accurate. So how could we improve it? Well, firstly, make sure there's no debris in front of the flow meter blades. Also, repeat it 3 times, and then make sure no other groups are upstream. They were all very obvious logical things to do if the problem is that there's people upstream or there's debris disrupting the flow. Then get rid of the debris, do it 3 times so you get a mean result, and make sure no groups are upstream. And then how would that improve your results? Will it mean they're more accurate and therefore they're more reliable when it comes to the conclusion? Because if our conclusion is based on data we've collected which is probably not accurate, okay, because it's been affected by the flow of people or the amount of people in the river, then our conclusion's not very reliable. We can't say with any certainty whether changes do occur downstream according to the Swannington Beck. Okay, and the second one is with the sediment roundness and size. The roundness guide is subjective. Power's roundness guide is something, well, you choose it. Now, one person's score of 3 or subangular or whatever it might be on the roundness guide might be someone else's rounded. Okay, it's not going to be that extreme, but there's different interpretations. Okay, so the impact on results is that you might get a different score when it could be the same, should be the same score, and the only way to improve that really is just make sure the same person is judging it every time, because that person will judge it the same. And that means that there's less opinion used, it eliminates variability of results, and again produces a more reliable conclusion. So again, you need to know this. This is stuff I would urge you to write down. Pause the screen while you do that, please, and I will then start to show you how this appears as exam questions. Okay, so here we go. This is a explain for 2 marks. Explain one limitation of the quantitative fieldwork method you used when investigating river discharge. So quantitative, about gathering data, lots of numbers. You need to name it. Again, specifically, you used, okay, to measure river discharge, and it's got to be quantitative. So specifically, you need to be looking at things like using a tape measure to measure river's width. Now, I didn't do that one, but that's a very commonly used one. The tape measure was not tight, or it was slack in the water. That meant that the river measurement was greater than it should have been, which created an inaccurate result. Again, it's only 2 marks, not huge. Accept other responses like velocity or depth. Do not accept reference to collection of sediment. Okay, now why is that important? Well, look at the question. It says measuring river discharge. When you pick up pebbles roundness, okay, pick up sediment, it doesn't tell you anything about the discharge. All it does is tell you if there's erosion processes going on. So measuring river discharge, we really only measured velocity, okay, because velocity links to river discharge. So this particular section would be what you would write in this answer. You'd say velocity flow, okay, measured. People standing upstream of us may have disrupted the flow, tick. This meant that our flow was slower than it should have been, tick. Okay, it doesn't have to be rocket science. It's very straightforward to get those 2 marks. Okay, here's the examiner's report. In this question, candidates were asked to explain one limitation of quantitative fieldwork. Many candidates found this question challenging due to misconceptions around the understanding of river discharge, and that's why I circled that when I looked at the question. Discharge is to do with methods like velocity or width and depth. Many candidates referred to sampling or sediment analysis rather than limitations associated with width, depth, velocity of a river. So they wrote the wrong thing. Candidates that did discuss the limitation of one of these methods were unable to develop their limitation further to explain why it was a problem. So really, again, what this is telling you is that students don't answer these fieldwork questions very well. I don't think that's hard. Okay, I don't think this is a tricky question. Everything's there for you. Explain for 2 marks, use a connective. It's a limitation, okay, so a negative of quantitative fieldwork method for river discharge. I've given you all of the different things you need. This is quantitative, it measures discharge. You should be able to then use that to create a 2-mark answer. I don't see why you shouldn't, so have a go if you're not sure. Okay, this is an example. Sorry about that, that's the windows automatically closing. So when measuring rivers width using a tape measure, it was difficult to achieve an accurate result because the speed of the water dragged the tape measure. It meant our results for river width weren't accurate. So river width, tape measure was difficult because speed of water dragged the tape measure. That's 1 mark. And then it meant our results weren't accurate. That's the 2nd mark. Okay. So that got the 2 full marks because they identified a limitation and then they explained how it impacted the results collected. Now, there's quite a lot when it comes to methods, and historically that seems to be a very popular area the exam board asks you about. So I'm going to show you even more questions, and what I want you to do, I'm not going to spend as much time on these ones. I would like you to maybe try them, pause the screen while you're trying them, and then I'll show you the mark scheme so you can see how you did. So this next one, explain one way you could have improved the quantitative fieldwork method. So looking at this here, okay, how could you improve the method? How would it improve your results? That's important. That's really the same question, but just further along that table. So have a go at this particular question. Pause the screen to do that now, please. Remember, it's explain for 2 marks how it could have improved the quantitative fieldwork method. Okay, here's the mark scheme. When measuring with the width, we could have recorded multiple measurements, which would have provided more precise profile of the channel. Or when measuring river velocity, we could have made sure that there were no people standing upstream, which meant that it wouldn't have disrupted the flow. Or we made sure we did 3 measurements, which created a mean of results which are more reliable. Okay, nice and easy. Should be easy anyway. So again, there's the examiner's report. Pause the screen and have a look at it. All right, it's worthwhile doing, and then we'll move on to the next bit. Okay, explain one way for 3 marks this time. The qualitative fieldwork method, and you can see, look, just how important it is that we know what these terms mean. Okay, qualitative fieldwork method you used supported your understanding of river landforms. Now this is where it's important to know that the exam board class sediment in rivers as landforms. Alright, so go back to that table I showed you, please. Have a go at answering this question, try and develop it, but explain one way your pebbles around, Powell's pebble roundness guide helped support your understanding of sediment in rivers, basically. Pause the screen to do that, and then I'll show you the mark scheme. Okay, so here you go. Look, this is evidence that if you ever wrote about this and didn't get the marks, I'm going to ring up the exam board and say, look, you've got a previous mark scheme that says we use Powell's roundness grading sheet to classify rock shape, tick. This showed the bed load got rounder downstream, tick. Supporting the Bradshaw model, tick. So clearly they class bed load as a landform. Please make sure you're aware of that. Don't be focusing on things like meanders, oxbow lakes. We don't have them in the Swannington Beck at our disposal. Okay, they've shown you all the things you could have mentioned. Waterfalls, nothing in Norfolk like that. Oxbow lakes, again, not. Slip-off slope, some in Norfolk but not near to us. Floodplain, loads of that. River management, channelization, whatever. So essentially just looking at this one is the one that you need to be focusing on. Okay, we do actually do annotated field sketch as well, but we don't look at a meander. Okay, we look at things like river flooding for that. So again, you could go down that route. Okay, again, this is the examiner's report, so pause the screen and read that so you can see where students got the marks or didn't get the marks. When you're ready, unpause. And there's another question. Again, methods of data collection questions are really, really commonplace. It's definitely worth you memorising that table or looking at that table, really going over it before this paper. So you have studied a river landscape as part of your fieldwork. Explain one, for 2 marks, advantage of a qualitative fieldwork method you used. So again, identify Powell's Pebble Roundness Guide. What's an advantage of using Powell's Pebble Roundness Guide? Okay, pause the screen, attempt an answer using the table so you can see how it links in, and then I'll show you the mark scheme. Okay, so here's the mark scheme. You get no credit for naming your qualitative method, but you'll get credit for explaining how it's an advantage. So this one goes on to, so again, look, Powell's roundness, you could accept. So again, it shows you can probably use that in most cases. But this one talks about field sketches, which again, we didn't do a field sketch. We did a sketch map, which is similar. So you could use the same principle. In my investigation, we used a sketch map to show the changes or to show the land around the Swannington Beck at 9 sites, tick. This meant it clearly showed the floodplain around the river or the areas around the river that could flood in future. That's the second tick. Okay, I know I've changed what this said, but we didn't use field sketches. I would go with the roundness question though. I'd say, in my river investigation we used Powell's roundness guide to measure sediment size. This meant that it was easy for us to judge what roundness we saw when taking sediment from the river. That would be a worthwhile answer. Okay, there's the examiner's report. Again, pause the screen, have a little read through of that, please. If there is a bell in a moment, please just ignore it. It's just the bell for the next lesson. And there's an example that got 2 marks. Again, you don't have to write loads. It's easy to compare a sketch of the upper course of the river to one of the lower course of the river, to compare the width from bank to bank. I wouldn't say this is a great answer, but it showed you they did a sketch, and what was good about the sketch, it was easy to compare the one in the upper course to the one in the lower course. Again, not the best answer, but it got 2 marks. Shows you just don't really know, you don't necessarily have to write a particularly brilliant answer to still access the marks, as long as you're just following what the exam would want you to do. Again, another question. Again, you might find that these are overwhelming you, but this is just huge practice for you when it comes to doing the assessment. So explain one way the secondary data you collected supported your investigation. So again, explain one for 3 marks, pretty common. It's got to be secondary data, so it can be any data that's been done or collected by someone else, and how it supported your investigation. So here you go, flood risk map, we've definitely got that in our investigation. How did that help? Again, I'm going to leave this one for you to look at because all 3 of these are decent kind of examples to show you. So pause the screen while you look at your answer and compare it to this mark scheme, please. Okay, so here's the examiner's report. Again, I'll leave that for you there to pause the screen and read through. And here's a pupil example for you to apply it. All right, so this pupil example achieved 3 marks. Okay, I'll just get rid of that. We used a GIS map of the geology of the river as we go downstream. This allowed us to, so that's worth 1 mark. This allowed us to overlay our results over it and see if the rock type influenced the river erosion. This was the case as the lower part of the river, the rock got softer and easier to erode when explained why the river became deeper and wider going downstream. So again, really clear, you've got the 3 marks there, the 3 aspects, and again it tells you why. Okay, this one is yet another question about methods, but this one's a big one. Okay, it's an 8 marker. So it says study figure 1 in the resource booklet. That tells you that this wasn't now about your fieldwork, this is about someone else's, and this is figure 1. It told you about the 3 methods they used. They measured depth, width and velocity. It told you how they measured it and the problems. Okay, so a summary table, much like we've got a few slides ago. It wants you to evaluate the accuracy and reliability of the fieldwork methods shown in figure 1. So it's an evaluate question, which means you need to give the positives, so the advantages and disadvantages of at least 2 of these methods, and a conclusion to say overall, are their methods reliable or not, and accurate or not. Okay, so structure this like any 8 mark evaluate question. If you don't know how to structure evaluate questions, go on to the 8 markers made easy revision PowerPoint, which you'll find in this very playlist. Okay, so evaluate the accuracy and reliability of the fieldwork method shown in figure 1. So you've got to talk about how they measured depth. You've got to read this. They did the depth in the middle of the channel at 3 sites. Is that accurate? I mean, yes, that's normally can be the widest part, unless you want to meander, of course. These sites were chosen because they were easy to access at the time. So, you know, a good aspect is that they could choose sites that were close by, good for access. A bad aspect of this is that they only went to the middle of the channel, which isn't necessarily going to be the deepest part. They talked to you about the problems, okay, that they encountered as well, which should help you evaluate it, but you've got to pick a few of these. Now, luckily, we've covered a lot of these in our own fieldwork, so you shouldn't be unfamiliar with these. Alright, so have a go if you want to have a go at this one. If nothing else, just to show you how you could structure 8 mark questions in this particular topic, and then I'm going to give you the mark scheme for that. Okay, so here's the mark scheme. This question requires candidates to evaluate the reliability and accuracy. So you can have a definition of what we mean by reliable and accurate. I've actually put that in here as well. So reliability is the extent to which the measurements taken are consistent. If they're reliable, they're done the same way each site. Accurate is whether they actually reflect what the true value of it is. So even though you can have things that are reliable but not accurate. So if they've done it the same way on every site, that's great, because they did. That you can see they were consistent. That they did it in the middle of the 3 sites, that's good. But is it accurate? Well, probably not, because that wasn't necessarily the deepest part of the river. It might be that they're on a meander, so therefore it doesn't give you the true value of depth. It might be that there was sediment on the bottom which lifted the tape measure up, which again didn't give you the true value of depth. So reliable and accurate are different things. Make sure you're commenting on those things. And here is a bit of the mark scheme that you can actually look at to see, just with examples of how people have answered this. Okay. There's the examiner's feedback. So again, pause the screen and read that. I know there's a lot there, but I absolutely guarantee you it's worthwhile doing that. Okay, it's worthwhile doing that for the purposes of your learning when it comes to exam questions. God, there's alarms going on all over the place. Hopefully it's not putting you off too much. Okay, section 5 is something about methods of data presentation. So you will need to know a variety of different presentation techniques, types of graphs, charts, maps, and the information they show, as well as understanding the advantages and disadvantages of those techniques. You'll also need to be able to justify why that technique is a good way to show the data that you've got, or why it might be a good way to show the data that someone else has got. But you also need to be able to evaluate, and again, evaluate comes into this quite a lot. The advantages and disadvantages of your method, what other methods might be suitable, that sort of thing. So, our rivers fieldwork in summary. We looked at a few ways of presenting data. Firstly, we did a scatter graph to show our discharge. So we did our sites downstream, we did our discharge in QMEX, and that measurement effectively gave us our sort of flow. So this measured discharge and distance, okay, to see if as distance downstream increases, a discharge increases too, because that would fit then the Bradshaw model, wouldn't it? So the advantage is it shows where there is a relationship between distance downstream and discharge, which we should see according to the Bradshaw model. But we don't have that many plots, and a lot of the plots are kind of a bit below anomalies, so it's not a very strong relationship there, I would say. It's a very weak positive relationship, and if we had more data, we'd see if that was actually more the case. But that's a problem with it being a small river anyway. So this is a summary of the fieldwork that you did. So if you haven't got this summary, you need to write this down and get it down for your notes now. Okay, that's one way we presented our data. Another way we presented our data was through bar charts. So when it came to the roundness, we could present it in a bar chart, or you could do this same thing if you wanted to do it for size of sediment. Okay, rather than being angular, subangular, whatever, you could have size of sediment from site 1, 2, 3, 4, 5, 6. So this only had 2 sites, site 1 and site 5, which again we'd urge you to do because you only did 3 sites. So site 2 and site 7 would be a good contrast. And the advantages show clearly whether sediment roundness changes with distance downstream, again in line with the Bradshaw model. But disadvantages are it's only 2 sites. So this actually isn't very reliable because we haven't got site 2, 3, 4, which would show us actually if this pattern or this trend is realistic. Okay, so we need to try and see a bit more data to see if it actually does have a pattern or a trend. Again, make sure if you haven't got all this information, which you should have from doing it in lessons, that you write this down. It's really important. Okay, and the final way that we could look at is we presented our data using a sketch map. So this isn't a sketch map, I know, but you created a sketch map from this OS map extract. Now a sketch map is good because it shows the whole study site, gives you loads of information about what's next to the river, the land use next to the river, the sort of land type in terms of like, is it flat, is it steep, the buildings nearby that are at risk of flooding. But it doesn't show actually areas that do flood, so you'd need to overlay this with a flood risk map like the one we've got from the Environment Agency, which we actually did do in the investigation. But if you are talking about the sketch map specifically, we didn't actually map the flood risk on our sketch map, which we probably could do. So that would be a way to improve it. So here's a question that links directly to that. So it's explain one advantage, okay, of the type of graph you use to present fieldwork data. Now you need to name a type of graph, and you've done 2, so you could do bar chart or scatter graph, and then identify an advantage of that. Okay, so pause the screen if you want to have an attempt at this, and when you're ready, unpause. Okay, so here is the the mark scheme excerpt from this, and it shows you again an example. So pause the screen to have a little look to see if this fits your answer. Here's the examiner's report. Read through that while you're pausing the screen. And here's an example of a pupil's answer, which nicely for us links to a scatter graph. So it got 2 marks, and this tells you why it got 2 marks. So if you want to see the answer, then pause the screen, and then if you want to see why it got the answer, unpause the screen, and I'll leave that one on there for you. Okay, so another question. This one's a big one, another big one. And again, it's evaluate. So you have studied a river as part of your geographical investigation. Evaluate, for 8 marks, the effectiveness of different techniques used to present your fieldwork data. So you must talk about at least 2 ways to present your fieldwork data, and that's why I haven't just said, oh, scatter graph is the answer for everything, because you need to talk about scatter graph here and probably the bar chart or a sketch map. Okay, if you want to have a go at this, I would again strongly urge you to have a go. Structure it like any evaluate 8 marker. Make sure you've got a conclusion as well. You need to write the title of your geographical investigation as well, but you need to be maybe mentioning, or I would certainly say mention scatter graph, and then pick one of the other 2 as your 2 paragraphs. Remember, give advantages and disadvantages of them. The last slides will really help you with this anyway. Okay, so hopefully you've finished that now. If not, pause the screen. I'm going to give you the mark scheme now. So here you go. Here's the mark scheme with some examples within it, okay, which are pretty handy for you. Pause the screen to have a little look. When you're ready, unpause the screen, and I'll give you the examiner's report as well. Okay, no examiner's report for this one. Sorry about that, I lied. So section 6, conclusions. You will need to know what conclusions you reached for your study. That's massively important, and I'll give you a summary here. You'll also need to be able to comment on how it helps your understanding of the topic of rivers as a whole. So the topic of rivers, which when we look at the Bradshaw model and changes from source to mouth, how did your fieldwork conclusions help your understanding of the rivers topic in paper 1, topic 1? How reliable were your conclusions? Okay, how well did they answer your hypotheses? So in summary, your fieldwork, okay, is there. I'm not going to read that out to you. This is something you should already have, but if you haven't, pause the screen and either screenshot it and highlight it and read it through, or write it down. As ever, there's exam questions to practice, and if there aren't any exam questions to practice, then you expect them to be occurring. So you need to know your conclusions for your river fieldwork. I've put them in really good detail for you here. This should be enough for you to actually use them for an exam situation. So pause the screen, and when you're ready, unpause, and I'll carry on. Okay, so here's some exam questions that could be asked. Now this one is actually not about your data, this is about someone else's data. So figure 1 and figure 1b, 1a, 1b, this is someone else's data presentation. Using both figures, okay, assess, 8-mark question, the possible conclusions that might be drawn from this river investigation. Okay, so this is all about conclusions. The good thing about this is these will be the same conclusions you probably got for your study, because again, Rivers fieldwork is pretty limited. There's not loads you can do, so that any questions they give you that are someone else's fieldwork are likely to be very similar to yours. Okay, clearly this shows you they've measured the river's width and depth. We didn't do that, but they have. We did velocity instead, and they've also measured roundness, which we did do. Okay, so looking at these two things, what conclusions can we have from site 1, 2, 3, 4, 5, from source to mouth? What happens to the river width? Well, clearly it gets wider and deeper. Does that fit the Bradshaw model? Yes. What happens to the roundness from site 1 to 5? Again, does it get more rounded as you go down from site 1 to 5? Yes. So there are conclusions really that this does fit the Bradshaw model. So even though we don't know what this investigation was, we can still assess the significance anyway of the conclusions. How significant is our conclusion that the sediment gets more round? Well, not that significant. Even though this is a pattern, we've only got limited data. It's a bit more significant when you look at the site 1 to site 5 when it comes to the width and depth, because it's very clearly a lot bigger, a lot wider. Okay, so that's just to kind of pinpoint you in that direction. Here comes the mark scheme for this, so just look out. There we go. It shows you in bullet point form the kind of things you could have mentioned. Okay, so pause the screen and have a look at that. And this is the examiner's report. So again, read through this. This answer, or the answer that a candidate that I'm going to show you, scored mostly 7 marks. You know, a lot of them got up to 7 marks. Most didn't get 8 marks because they maybe didn't assess. If you don't assess, okay, then you won't get full marks. And remember, the same rules of assess apply. That's this bit at the bottom here. You need a conclusion from your assessment, and you need to say which one of the bits of fieldwork was the most significant, the most convincing, the one that gave you the best conclusions, okay, and which one, conversely, isn't very reliable. If you can do that, then you can fully assess this candidate's fieldwork. Okay, so overall evaluation. This is the very final section that you could be asked about when it comes to fieldwork questions. So you need to know what your overall reliability and accuracy, those 2 words again, okay, of your fieldwork investigation was. You also need to think about other things that you could do to improve the fieldwork overall. Not improve the methods of data collection, improve the overall fieldwork. Now, often this will be go at different times of year, go at different sites or more sites, go to different rivers to compare, okay? So your fieldwork summary, okay, and again, I'm just going to put all of this on the screen for you. So you've got all the answers there. I'm going to let you pause the screen to make sure that either you've already got all this or you write it down right now, because it's absolutely critical that you've got this information. Okay, pause the screen while you do that. When you're ready, unpause the screen, please. Okay, so frustratingly, from a practice point of view, there have as of yet been no rivers questions about the overall evaluation of a river study. Again, you need to consider this because this is something which means that it's likely to come up in a new exam series or a future exam series. I absolutely see evaluation and overall evaluation of the study as a critical part of fieldwork, so it's something we can't ignore. So you need to know this stuff really, really in detail to be able to quote for an exam question. And if there's an exam question on it, I expect it to be an 8 marker, because 8 markers fit nicely with when it comes to looking at evaluating. All right, so as unhelpful as that is, I'm afraid that is that's the final part of this study. Hopefully by going through how your study fits in, you've been given a full summary of your fieldwork in the Swannington Beck. Hopefully also you've been able to show or see how it links to exam questions and how you construct your answers to get good marks for those exam questions. This is always an area and a paper which students score lower on in general, and I'm sure from reading the examiner's report bits you saw that actually a lot of the time they were saying candidates didn't answer this very well, they didn't answer this very well. Don't see that as this is a hard paper, see that as this is a great opportunity for me to outscore other candidates across the country and boost my grade, because I don't think these are too tricky. If you know your fieldwork inside out, then you will be absolutely set up to get a really good score here, and it's very likely to stand you in good stead when it comes to outcompeting all the other candidates, which is what the grades and the grade boundaries are based on at the end of the day. Alright, thank you very much for listening. I know it's been a long slog, but it's definitely worthwhile you going over it and having a look back through some of these questions as well. Thank you for listening, and I'll see you next time.